Section 9.1 is square roots. I can find and approximate square roots of numbers. A square root of a number n is a number m such that m squared equals n. What they're saying is the square root of a number like 9 is a number such like 3 because 3 squared equals 9. Every positive number has two square roots. One square root is positive and the other is negative. And that's because 3 times 3 or 3 squared equals 9, but negative 3 times negative 3 or negative 3 squared also equals 9. So if we take a positive times a positive or a negative times a negative, we get to the same value. The radical sign represents the non-negative square root. So if we see something like the square root of 7, we know it's positive. Okay, if they wanted us to have both the positive and the negative, we'd have to have a plus or minus sign in front. Now, if we just want to know what's the square root of 9, our options are 3 or negative 3. But when they write it already, this is called our principal root. And it's because they don't have a sign in front, so we know it's positive. Just like if we see a 6, we know it's positive. Same idea there. So in example 1, Italy has a chessboard with an area of 324 square meters. The length of each side is the square root of 324. What is the length approximately? So here what it's telling us, guys, is that we have a square and each side is the square root of 324. We're looking for what number can we square to get to 324. What number times itself gives us 324. Here I've put on a chart of perfect squares from 1 to 30. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. On the board in my room, I have up to 20 squared, so these extra ones are here. We're looking for 324, and that's 18 squared. So here, the side lengths are going to be 18 times 18 to get to 324. So the square root of 324 is 18 meters. And usually when we take the square root, guys, it's plus or minus, but we can't have a minus length here. Okay, it tells me it's meters and square meters. So our length is in meters, and we can't have a negative distance. Here, feel free to pause and give these a try if you'd like. We're going to find the square roots of each number. In number 1, it's 16. So if we look at our chart, 16 here means I took 4 times 4. But I also could have taken negative 4 times negative 4, because 4 times 4 gives me 16, and negative 4 times negative 4 gives me positive 16. So here, plus or minus 4. 64, I look at my chart of perfect squares, and I find 64. And to get to 64, I take 8 times itself. So the number that I would square to get to 64 is 8, which means that is my square root. But it's not just positive 8 times positive 8. I also could have taken negative 8 times negative 8 to get to 64. 144 is 12 times 12. The number I square to get to 144 is 12. And again, it could have been positive 12 times positive 12 or negative 12 times negative 12. And 256 is 16 times 16. So the square root of 256 is positive 16 times positive 16, or I could have taken negative 16 times negative 16. And again, to find our square root, we're looking for what number did we have to square to get to our value. A perfect square is a number that is the square of an integer. We can use perfect squares to approximate a square root of a number. So perfect squares are numbers like 1, 4, 9, 16, 25, 36, 49. Okay, we get them by taking any number, so 8 and squaring it, 64. 14 squaring it, 196. Those are perfect squares. To approximate a square root to the nearest integer, we're going to compare our number underneath our radical sign. We call that our radicand, 51. And we're going to find where in our list of perfect squares 51 would fall. 51 falls between 49 and 64. So 51 is between 49 and 64. Then we check, which one is it closer to? Well, 51 is only 2 away from 49 and 13 away from 64. So it's closer to 49. Now, keep in mind, we don't have just 51, we have the square root of 51. So the square root of 51 is going to be close to the square root of 49, and the square root of 49 is 7. So here it's 7, and it's just 7 because they gave us the principal square root. Here they show us that it's positive, so we only want the positive 7. Now, feel free to pause here and give this a try if you'd like. We are going to approximate the square root of 125 to the nearest whole number. So 125 is in between 121 and 144. So 125 is in between 121 and 144. Now, we have to check and see which number is it closer to. Here I'm 4 away, here 19 away. So I'm closer to 121. But we don't have just 125. We have the square root of 125, which means I also need the square root of 121. If we look, 121 is 11 times 11. So the square root of 121 is 11, which means 125 is approximately 11. It's a little bit more, but to the nearest whole number, it'll be 11. Again, take our radicand, our number underneath our radical sign, and compare it to our other perfect squares. 125 falls between 121 and 144, but it's closer to 121, which means its square root is going to be close to the square root of 121, which is 11. In example 3, we're going to use a calculator to approximate the square root of 515. We're going to round to the nearest tenth. So if you have a TI 30 two-line like the one on my wall at school, we're going to press the second key, then we're going to press the x squared key. And if you look above that, it'll have a little square root symbol. And we get that square root symbol again by pressing the second first. So we'll do second x squared to get our square root, and it has a parenthesis there with it when it comes up on your screen. We'll type in 515. Close your parenthesis, just a good practice to get into, and press equals. Rounding to the nearest tenth, so right now I have 22.6936. To round to the nearest tenth, that's one decimal place. So we look at the number behind it. 9 rounds up, so it's going to be 22.7. So it's approximately 22.7. A radical expression is an expression that involves a radical sign. So a square root, for example. The horizontal bar in a radical sign is a grouping symbol, just like if it was parentheses or a fraction bar. When you evaluate a radical expression, evaluate the expression inside the radical symbol before finding the square root. And that's because of PEMDAS. PEMDAS says we need to do parentheses or any grouping symbols first. So again, the bar here on my square root is kind of like a parentheses. We have to do whatever's inside there first. So here, I keep my entire expression the same, except anywhere I see an A, I plug in the value, and everywhere I see a B, I plug in my value. A is 11, and B is 5. Now, PEMDAS says we have to do parentheses first, so again, we're going to go inside our square root, and according to that, I have to do exponents first, so I'm going to keep my 11, and take 5 squared, which means 5 times 5, or 25. Now, I'm going to add 11 plus 25 gives me 36. And now, since my parentheses part of my expression inside my grouping symbol there has been simplified as far as I can take the square root. And the square root of 36 is 6. 6 times 6 is how I get to 36, or 6 squared. So here, the square root of 36 is 6. And because they have it written as a square root, guys, we only want the positive square root of 6. Then I can actually finally multiply by 2, and I get 12. Feel free to pause here and give this a try if you'd like. We're going to evaluate the expression when A is 12 and B is 4. So again, I'm going to keep my expression the way that it's written. And instead of writing A, however, I'm going to write a 12. And instead of putting in a B, I'm going to plug in a 4. Now, my square root itself is a grouping symbol. So I'm going to do whatever's inside my square root first. 12 plus 4 is 16. And then I can finally, once it's completely simplified, take my square root. And the square root of 16 is 4. 4 times 4 is how I get to 16. And we want the principal root because it's positive here. We only want a positive 4. It's already showing us what type of answer we want. Try 7. Square root of b squared minus a. Everywhere I see a b, I'm going to plug in a 4. Everywhere I see an a, I'm going to plug in a 12. According to PEMDAS, we have to do our exponents first. 4 squared, 16 minus 12. I can take 16 minus 12, which is 4, and finally take my square root. And the number that I can take times itself to get 4 is 2. So the square root of 4 is 2. In 8 here, I have 3 times a times b plus 1 inside my radical. So again, I kept everything the same, except wherever I see an a, I plug in a 12, and wherever I see a b, I plug in a 4. Again, inside our square root is a grouping symbol, so we need to do all of that first. We're going to do multiplication. Bring down the rest of our problem. Then we can do our addition. And now we can finally take our square root. Square root of 49 is 7. And remember, that's still being multiplied by 3. And here we're finally going to get 21 as our final answer. And that's all I have for section 9.1.